next lecture of chapter 13, class 9 mathematics, surface area and volumes. So in this lecture we will talk about the surface area and volumes related to spheres and hemisphere. So first of all we are going to talk about what a sphere is. So if we talk about the shapes, we are saying the football, volleyball, throw ball, all these shapes, these are of these objects, these are of the shape of a sphere. And the mathematical definition for this we can give that if a circle is there and suppose this is the diameter of this circle, we are saying this is the diameter of this circle, and we fix it over here and we start rotating this circle like this, then the shape that will be generated, that is called the sphere. And the radius of this circle, that is the radius of this sphere, and center of this circle, that is the center of the sphere. So we are talking about the shape of the ball, we are talking about it is the sphere. So if we talk about the volume and surface area, these are the formulas for the volume and the surface area that you have to remember. That the volume of the sphere is 4 by 3 pi r cube and surface area of the sphere is 4 pi r square. 4 pi r square means it is basically, we are saying it is 4 times pi r square. So what we are saying is that the surface area of the sphere is equal to the 4 times the area of the circle from which it is generated. So these two formulas you have to remember, that the volume is 4 by 3 pi r cube and the surface area is 4 pi r square. Next is the spherical shell. So we are saying suppose two spheres are there. This is one sphere. Sphere generally we represent in two-dimensional plane with the help of a circle. So we are saying spherical shell means that this is the inner radius over here, this is small r, and the outer radius over here it is capital R. So spherical shell means we are talking about this kind of shape over here, that it is hollow from inside. So or you can say it is solid and closed between the two concentric spheres. Concentric means their center is same. So this is called the spherical shell. So the volume of this outer shell, that will be 4 by 3 pi capital R cube, and volume of this internal shell will be 4 by 3 pi small r cube. So when we solve this value, we will get it is 4 by 3 pi into capital R cube minus small r cube. So this is the volume of the spherical shell. Next we are talking about the hemisphere. Hemisphere means that suppose we have a sphere over here, we are talking about a ball, shape of the ball, and we cut it from the half. This is the midpoint. We cut it from the half, so we will get some shape like this. This is called the hemisphere. So the volume of the hemisphere will be half the volume of the sphere. Volume of the sphere is 4 by 3 pi r cube. So volume of the hemisphere will be half of this. So the formula we have, it is 2 by 3 pi r cube. Curved surface area of the hemisphere means we are talking about this area. The area of the whole sphere was 4 pi r square. Now the area of the hemisphere will be, it is divided by 2, so it is 2 pi r square. And total surface area of the hemisphere means we are talking about that this region is also covered now. So the area of this region, it is the area of the circle, it is pi r square. So it is 2 pi r square plus pi r square, and the final answer we will get, it is 3 pi r square units. So this is the total surface area of the hemisphere. Now the first question we have is find the volume and the surface area of a sphere of radius 21 centimeter. So radius of the sphere is given to be 21. We have to find the volume first. The formula for volume, it is 4 by 3 pi r cube. So it is 4 by 3, pi is 22 by 7, radius is 21, so it is 21 into 21 into 21. And when you will solve this value, this whole value you will solve, you will get The answer is 38808. The units for volume, it is centimeter cube. Similarly, when we are talking about the surface area of the sphere, the formula we have, it is pi r square, so it is 4 pi r square, so it is 422 by 7, and r square is 21 into 21. So the final answer that we will get, it is 5544 centimeter square. So this is centimeter square. This is the unit of the area. Next, we have to find the surface area of a sphere whose volume is 4851 centimeter cube. So formula for volume is 4 by 3 pi r cube, and its value is 4851. So what we get is r cube is equal to 4851 into 3 into 7 by 4 into 22. We are writing this pi is 22 by 7. When you will solve this value, you will get this r is equal to 21 by 2 is equal to 10.5. These calculations for solving this, these are shown over here, that how we are solving these values. We are multiplying these values, and you will get that this total answer we are getting, it is 21 cube over 2 cube. Then we are taking the cube root on both sides, and we are getting the r is 21 by 2, that is 10.5. Now we have to calculate the surface area. So for surface area, the formula we have, it is 4 pi r square, so it is 4 into 22 by 7. The radius we are saying, it is 21 by 2 into 21 by 2. Again, when we will solve this value, we will get the answer is 1386 centimeter square. Now next we have the surface area of a sphere is 346.5 centimeter square. We have to find the radius and the volume. So the formula for surface area we have, it is 4 pi r square, that is equal to 346.5. So r square is equal to 346.5 into 7 by 22 into 1 by 4. This thing we are writing, it is 22 by 7. So when you will again solve these values, you will get the answer is 441 by 16. This 441 by 16, and 441 is square of 21 by 4 whole square. So we will get the value of r is 21 by 4, that is equal to 5.25. Next we have to find the volume. So what we have is the radius is 5.25. So the formula for volume is 4 by 3 pi r cube. So 4 by 3 pi r cube means 4 by 3, pi is 22 by 7, and r cube means it is 5.25, 5.25 and 5.25. So this 5.25 we can write over 100, over 100, over 100, and in the numerator we are having 525, 525 and 525. So the final answer we get over here, it is 4851 over 8, that is equal to 606.375 centimeter cube. So in these questions we are saying the calculations are a bit lengthy. Calculation means we are talking about we have to multiply these terms, we have to divide these terms, but the basic formulas that are just the formula for the area and the volume, that are directly applicable over here. But while solving or while performing the multiplications, square root, it may take some time to calculate these values in these questions. Next is, how many spherical bullets can be made out of a solid cube of lead whose edge measures 44 centimeter, and the diameter of each bullet is 4 centimeter. So we are saying the block is there. This is the cubical block whose side is 44 centimeter. This is 44 centimeter and height is 44 centimeter. And we have to make the spherical bullets of diameter 4 centimeter. So radius of this thing will be 2 centimeter. So what will be same over here? The volume will be same over here, that whatever the volume of this is there, Suppose we are saying there are n bullets that are formed, then the volume of these n bullets and volume of this lead, they should be block of lead, this should be same. So volume of the block of lead is 44 into 44 into 44, and the volume of n bullets, we are saying it is 4 by 3 into pi into r cube. R cube is 2 into 2 into 2. So what we have to calculate is we have to calculate the value of this n. So we get n is equal to 44 into 44 into 44 into 3 into 7 over 4 into 22 into 2 into 2 into 2. So this 22 and 44 gets cancelled, then this 4 and 44 get cancelled, then this 4 and 44 gets cancelled, and the final answer we are left over here, that will be, so this 2 and this 2, this will become 4, and when these two are cancelled it will be left with 11, and when we multiply these terms we will get it is 2541, and this is the value of n that we have, that is the number of bullets that will be formed. So what we see from this question is that if the lead box is given and we have to form the bullets, so what will be same in between these two, that the total volume of the lead will be same. Next we have is the diameter of a copper sphere is 6 centimeter. So a sphere is there and its diameter is 6 centimeter. This is the center of the sphere. The sphere is melted and drawn into a long wire of uniform circular cross section. So this sphere is melted and a wire is formed of uniform circular cross section. Cross section means if we cut it from anywhere, the section over here that is circular. So basically we are talking about that the wire is in the form of a cylinder, right? Circular cylinder. If the length of the wire is 36 centimeter, we are saying the length of this wire formed, it is 36 centimeter. We have to find its radius. So what is done over here, that block that is given to us, this copper block, this is melted and it is converted to a wire. So what will remain same over here, it is the volume will remain same over here. So volume of this sphere will be 4 by 3 pi r cube. The radius over here, that will be, this is diameter is 6, so radius is, we are saying it is 3 centimeters. The value of radius that we will have, it is 3 centimeters. Now the volume of this cylinder, it is pi radius. Suppose we are saying the radius of this cylinder, it is small r, so we are saying it is pi r square, and height it is 36. Now the radius over here, it is 3 cube. So what we get is, it is 4 by 3 into 22 by 7 into 3 into 3 into 3, that is equal to pi r square into 36. This pi gets cancelled, this 3 gets cancelled, and what we get is r square is equal to 4 into 9 by 36. So that will be equal to 1. So the value of r that we will get, it is equal to 1, and this is the radius of the wire that we have to calculate, that is the value of r that we get is 1. Now next we are given that a metallic sphere of radius 21 centimeter. So we are saying a sphere is there whose radius is 21 centimeter, and a cylindrical vessel is there. We are saying, suppose this is the cylindrical vessel, and this vessel, it is partly filled with water. Partly filled with water means that water is up to, suppose, say this level, and this sphere is submerged completely in, this sphere is submerged completely in this vessel. We are saying this is over here, this sphere is over here. And when we place this sphere in this vessel, the level of water will increase. Suppose the water level increases to this point. Now we have to find how much level of water has increased. If the diameter of this vessel, the diameter of this vessel is 1.68 meter, that is 168 centimeter. So the radius of this vessel will be 84 centimeter. So we have to calculate this height over here. Suppose we are saying the level of the water that is increased is h. So what we have to find is, we have to find the volume of this region. We are saying that the volume of this much water, that will be equal to the volume of this sphere, because earlier the level of water was up to this place. Now how much water will be displaced, that will be equal to the volume of this sphere. We are saying the volume of the water displaced by the sphere, that will be equal to the volume of this sphere. So volume of this portion I am talking about, volume of this portion, this shaded portion I am saying, its volume is pi, radius over here it is 84 square, into height of this portion it is h, and volume of the sphere we know it is 4 by 3 pi, and radius of the sphere is 21 cube. So this pi gets cancelled. We want to calculate the value of h. So that will be 4 by 3 21 into 21 into 21 over 84 into 84. So this 21 and 84, it is 4 over here, this 4 gets cancelled, then 21, and this is 4 over here, and this is 3 7 the 21. So the value of h that we get, it is 7 by 4 is equal to 1.75 centimeter. So we are saying the height with by which this water level will increase, that height will be equal to 1.75 centimeter, and this is what we have to calculate. Now the next we have, it is a hollow sphere is there, and the internal and the external diameters are 8 and 4 centimeters. So internal radius is 2 centimeter and external radius is 4 centimeter, and this hollow sphere, this is melted to form a cone, the diameter of whose base is 8 centimeter. So it means this radius over here, it is 4 centimeters. So we have to find the height of the cone. So what will be same over here, the volume will be same, the volume of this hollow sphere and volume of this cone will be same, because it is melted and it is formed in the sphere is melted and the cone is formed from that material. So we are saying that the volume in both these cases, it is same. Now suppose the height over here, it is h. So the volume of this sphere will be 4 by 3 pi, it is r cube. So we are talking about the volume of the external part of this sphere, that will be 4 by 3 pi r cube, and the internal part will be minus 2 cube, and this should be equal to the volume of the cone, that is 1 by 3 pi r square into h. So this 3 and pi, these gets cancelled over here, and we are left with, it is 4 into, this is 4 cube minus 2 cube. So it is 64 minus 8, that is equal to 4 square into h. So we are saying 1 4 gets cancelled over here, and if we take 4 common from this, so what we are left with is 16 minus 2 is equal to 4h. This 4 also gets cancelled, so we get that the value of h, it is 14 centimeters. That is, the height of this cone is 14 centimeters. Next is find the volume, curved surface area and total surface area of a hemisphere of diameter. This is a hemisphere that is given to us, and its diameter is 7 centimeter. It means its radius is 7 by 2 centimeter. Now the formula for the volume is 2 by 3 pi r cube Then we have to find the curved surface area. So the formula for the curved surface area will be 2 pi r square, and the total surface area will be 3 pi r square. This is because the volume of the whole cone is 4 by 3 pi r cube. So it is half of this value will be this. Then this total surface area of the sphere is 4 pi r square. Half of its value is this. If we add to it the area of a circle, we will get it is 3 pi r square. That is the total surface area of the hemisphere. The value of radius we have it is 7 by 2. So we substitute these values in these formulas. It is 2 by 3 pi r cube. When we solve this value, we will get it is 89.83 centimeter square. Second, to calculate the curved surface area, it is 2 into pi into r square. So it is 77 centimeter square. And the third thing we have to calculate is 3 pi r square. So it is 115.5 centimeter square. So these are the three things we have to calculate for this hemisphere. Next is the internal and external diameter of a hollow hemispherical vessel is. We are talking about the internal diameter over here. So it means we are talking about this internal radius. It is 10 centimeter. And this external radius over here. This is 14 centimeter. The cost of painting the vessel all over at 35 paise per centimeter square. So we have to find the total surface area of this hemispherical vessel. So we have three portions over here. One is this internal portion, one is this external portion, and one is this part over here, that is the circular part like this. So we know the formula for the surface area over here. It is 2 pi r square. So in this case we will get it is 2 pi. We are talking about the external part, so it is 14 square. For the internal part, it is 2 pi into 10 square. Now the area of this region, these are this top portion we are talking about, this portion we are talking about, the area of this portion will be, the area of this inner circle will be pi r square, means 10 square, and area of this outer portion will be pi 14 square. So what is the total area over here? It is 2 pi 10 square plus 2 pi 14 square plus the value of this area will be pi 14 square minus 10 square. So from these two terms we will get 2 pi common, and we are left with this 100 plus 14 square, and the value of 14 square we have it is 196 plus pi into 196 minus 100. Again pi is common from these two, and we get it is 2 into 296 plus, and this value we have it is 96. And on solving these values, we will get that the total area we will have it is 688 pi centimeter square. So this is the value of 688 pi centimeter square. This is the total area to be painted. We are talking about the total area to be painted. It is 688 pi centimeter square. So the next thing that is given to us is that to cost of painting the vessel is 35 paise per centimeter square. So we are saying that to paint 1 centimeter square, the cost is 35 paise, that is 35 by 100 rupees. Now the total area we have it is 688 pi. So 688 pi centimeter square area is there. To paint this area, the cost will be 35 by 100 into 688 pi. And when you solve these values, it is 688 pi into 35 into 100. So it is 22 by 7 in place of pi. And you will solve this value, you will get the answer is 756.80, rupees. Now the next question we have is on increasing the radius of a sphere by 10%. So suppose we are saying that the original radius of the sphere it is r. Now the new radius will be, we have increased the radius by 10% means r into 10 by 100, it is r plus this. So this is equal to 10r plus r by 10, that is equal to 11r by 10. So this is the value of the new radius of the sphere. We have to find the percentage increase in its volume. So the volume of the sphere with radius r, it is 4 by 3 pi r cube. This is V, and the new volume we have, it is Vn. New volume we are saying it is 4 by 3 pi. The new radius is 11 by 10 r cube. So 4 by 3 pi gets cancelled, and what we are left over here, it is r cube by 11 by 10 cube into r cube. So it is equal to 1000 by 11 cube. The value of this 11 cube we have, it is 1331. So this is the, we are saying this is the ratio of the two volumes. Now what we have to find is, we have to find the percentage increase in volume. So to calculate the percentage increase in volume, we are talking about percentage increase in volume. The formula we have, it is the original volume V, and then in the numerator we will have the new volume minus the original volume and whole multiplied with 100. So this is equal to Vn over V minus V into this Vn minus V, this is minus 1 into 100. So what is the value of Vn over V? It is 1331 over 1000. Then it is minus 1 into 100. So the answer we will get over here, when we will solve this value, you will get and you will solve this value, it is 1.331 minus 1 into 100. So it is 0.331 into 100. So that is equal to 33.1%. So we are saying this is 33.1%. This is the percentage increase in the volume when the radius of the sphere is increased by 10%. We are saying when the radius of this sphere it is increased by 10%, then the percentage increase in volume is 33.1%. Now the next thing we have is the surface area of a sphere of radius 5 cm is 5 times the area of the curved surface of a cone of radius 4 cm. So a sphere is given to us whose radius is 5 cm and a cone is given to us and its radius is 4 cm. The volume of the sphere and volume of the cone are there, and it is given that the surface area, these are the surface area, surface area of sphere and surface area of cone we are talking about. This is the curved surface area of cone, and it is given that the surface area of the sphere is 5 times the surface area, curved surface area of the cone. We have to find the height and volume of the cone. So we suppose that the height of this cone it is h and the slant height it is L. So the surface area of the sphere will be, it is 4 pi r square means 5 square. It is equal to 5 times the curved surface area of this cone, and we know the formula for the curved surface area of the cone, it is pi into r into L. So this 4 gets cancelled, 5 get cancelled, and this pi get cancelled, and the value of L we get, it is 5. So if the value of L is L means we are talking about the slant height. We are talking over here. The value of L is 5 and the radius is 4. Then the value of h we will have, it is square root of 5 square minus 4 square, that is equal to 25 minus 16 square root of 9, that is equal to 3 centimeters. So this is the height of the cone. Next we have to calculate the volume of the cone. So the volume of the cone will be 1 by 3 pi r square h. So it is 1 by 3. It is given that we have to take the value of pi is 3.14. So we are not taking 22 by 7 over here. We are taking the values 3.14. The radius is 4. So it is 4 into 4. And the height we have calculated, it is 3 centimeter. When we will multiply these values, this 3 gets cancelled over here. And when we multiply these values, we will get the answer is 50.24 centimeter cube. And this is the volume of the cone. So we have to find the height, it is 3 centimeter, and volume, it is 50.24 centimeter cube. Now next we are talking about the volumes of two spheres are in the ratio of 64 is to 27. So we are saying that the volume V1 over V2, that is equal to 64 over 27. We have to find the ratio of their surface areas. So formula for the volumes, it is 4 by 3 pi r1 cube over 4 by 3 pi r2 cube. This 4 by 3 pi gets cancelled. So what we get is r1 over r2 cube, that is equal to, this is 4 by 3 cube. So this gives us r1 over r2 is equal to 4 by 3. We have to find the ratio of their surface areas. So ratio of surface area means we are talking about S1 over S2. So the formula for surface area, we know it is 4 pi r1 square over 4 pi r2 square. This 4 pi gets cancelled. So we are getting r1 over r2 square, that is equal to 4 by 3 square. So it is equal to 16 by 9. So we are saying the ratio of the surface areas is 16 is to 9. Next we have a sphere and a right circular cylinder of the same radius. Suppose the radius of this sphere and radius of this cylinder there are, and both of these have the volume V. By what percentage does the diameter of the cylinder exceeds its height? So suppose the height of this is h. So what we have is both the volumes, they are equal. So volume of the sphere, we know it is 4 by 3 pi r cube, and the volume of the cylinder we know it is pi r square h. So this pi gets cancelled, r square and r cube, we are left with r. So what we get is that the ratio we have to calculate over here, it is by what percentage does the diameter of the cylinder exceed its height. So the percentage that we have to calculate, it is, so the percentage we are talking about, it is basically we are talking about the original value we have h, and we have to find that by what percentage the diameter exceeds the height. So diameter means we are talking about, this is 2r over here minus h into 100. Why we are writing it like this? We are saying by what percentage does the diameter of the cylinder exceeds the height. So height comes in the denominator, and we have to find the diameter exceeds the height. So it is 2r minus h in the numerator. When we will solve this value, we are left with 2r over h minus 1 into 100. So it means we require the value of r over h. So from this we will get r over h is equal to 3 by 4. So substituting this value over here, it is 2 into 3 by 4 minus 1 into 100. So this is equal to 6 minus 4 by 4 into 100. So this is equal to 2 by 4 into 100. So that is equal to 50. So the answer we get is the excess of diameter of the cylinder over its height. The percentage we have, we are saying the excess percentage is 50%. Now this thing is important over here, that how we are writing this value over here, why we have taken h in the denominator and why we are taking 2r minus h in the numerator. It just comes from that what is being asked, that the question asked is percentage, what percentage does the diameter of the cylinder exceed its height. So we are talking about the basic thing from which we are comparing, it is height. So height comes in the denominator part, and what we are trying to calculate is that how much is the difference between the diameter and the height. So it is, we are writing it is 2r minus h in the numerator, and we want to calculate the percentage, so it is percentage over here. So this part is important over here, that how we are writing this part, it is important over here. Rest of the thing, these are just the calculations. Now the next we have is the water for a factory stored in a hemispherical tank whose internal diameter is 14 meter. So we are talking about a hemispherical tank is there, and its internal diameter that is given to us, it is 14 meter. So it means the radius over here, it is 7 meter. The tank contains 50 kiloliters of water. Now it is 50 kiloliters of water. So water is pumped into the tank to fill to its capacity. Calculate the volume of water pumped into the tank. So what we are saying is that already existing level of water, it is 50 kiloliter. So 50 kiloliter means we are talking about it is 50 meter cube. 50 kiloliter means it is 50 into 1000 liter. 50 kiloliter means we are talking about 50 into 1000 liter, and this value comes out to be 50 meter cube. So what we have to calculate now is we have to calculate the volume of this whole tank. So the volume of this tank will be 4 by 3. This is a hemisphere, so it is not 4 by 3, it will be 2 by 3. Pi is 22 by 7, and then it is r, radius over here it is 7, so it is 7 cube. And when we will solve this value, we will get the answer is 2156 by 3 meter cube. So the capacity of this tank, the capacity of this whole tank, that comes out to be 2156 by 3 meter cube. The water that is already present in it, it is 50 meter cube. So how much more water is required means we are talking about how much more water we need to fill. We want to find this, so that will be 2156 by 3 minus 50 meter cube, and the answer comes out to be 2006 by 3, that is equal to 668.67 meter cube. So we are getting that this is the amount of water that need to be pumped into this tank to fill this tank completely. Now next we have a shopkeeper has one spherical laddu of radius 5 centimeter. This is 5 centimeter radius, and with the same amount of material, how many laddus of radius 2.5 centimeter can be made. So he breaks this and he forms new laddus of radius 2.5 centimeter, and we have to calculate how many such laddus can be made. So basically, suppose we are saying there are n laddus that can be made over here. So the volume of these n laddus and the volume of this one laddu should be same. We are saying the volume of both these should be same. So volume of this one laddu, it is 4 by 3 pi r cube, and volume of these n laddus, it is 4 by 3 pi r cube. So 4 by 3 pi gets cancelled, and the value of n we get, it is 5 into 5 into 5 over 2.5 into 2.5 into 2.5. So it is 2, 2 and 2. So the answer we get, it is 8. So from this one laddu of radius 5 centimeter, he can make 2.8 laddus of radius 2.5 centimeter. So we are given a shot put is a metallic sphere of radius 4.9 centimeter. So we are saying that a metallic sphere is there and its radius is 4.9 centimeter. If the density of the metal is 7.8 grams per centimeter cube, we have to find the mass of the shot put. So it means the volume we have to calculate, and the formula volume it is 4 by 3 pi 4.9 cube. Now we are saying this is centimeter cube, this is the volume of this metallic sphere. Now 1 centimeter cube, its weight is 7.8 grams. So we have to find the weight of this much, 4 by 3 pi into 4.9 cube centimeter cube we have to find. So it is 4 by 3 into 22 by 7 into 4.9 into 4.9 into 4.9 into 7.8, this much grams. And when we will solve this value, we will get the answer is 3845.4 grams. And when we convert it to kg, we are talking about in place of grams, we are converting it to kg, so we have to divide it with 1000. So dividing it with 1000 means it is 3.845 kg. So the weight of this, the mass of this shot put is 3.85 kgs. Now next we have two solid spheres made up of same materials have weight 5920 gram and 740 gram. We have to determine the radius of the larger sphere if the diameter of the smaller one is 5 centimeter. So what is given to us is that the density of both these materials, it is same because they are made up of same material. So suppose we are saying that the density we have, it is d grams per centimeter cube. So the volume, this value, the density, this is the weight over here we are talking about, and weight we know that this is equal to volume into density. So what we get is that the volume of the larger sphere into density over volume of the smaller sphere into density, that will be equal to 5920 over 740. These two d gets cancelled. Now the volume of the larger sphere, it is 4 by 3 pi r cube, and the radius of the smaller sphere that is given to us, it is 5 by 2. So its volume is 4 by 3 pi into 5 by 2 cube, and that is equal to, when we solve these two values, we get it is 8. This 4 by 3 pi gets cancelled. So what we get from this is that r cube is equal to 8 into 5 by 2 cube. So this is equal to 2 cube into 5 by 2 cube. So that is equal to 5 cube. So the value of r we have, it is 5 centimeters. And this is what we have to calculate. This is the radius of the larger sphere. So radius of smaller sphere is 5 by 2 and radius of larger sphere, it is 5 centimeters. So what we have used over here is that it is made up of same metal. It means their density is, we are talking about they are made of same metal, means that this weight over here, this will be volume into density. In both the cases density is same, so we get that this VL over VS, that is volume of the larger sphere and volume of the smaller sphere, their ratio is just the ratio of the two weights that are given over here. Next, a hemispherical tank is made up of an iron sheet 1 centimeter thick. So we are given a hemispherical tank over here, and it is given that this is made up of an iron sheet which is 1 centimeter thick. So this is made like this. What this thing means, that this thickness over here, we are talking about this thickness over here, it is 1 centimeter. And the inner radius of the tank is, we are talking about this inner radius over here, it is 100 centimeter. It is 1 centimeter thick, means that the outer radius over here, it is 101 centimeter. you have to find the volume of the iron used in the tank. So the volume of this outer portion will be, it is 2 by 3 pi. We are talking about this outer portion and its radius is 101 cube, and this inner volume we are talking about, it is 2 by 3 pi into 100 cube. So the volume of the iron used will be difference of these two. We have shown this calculation over here that 2 by 3 pi is common, and we are left with is 101 cube minus 100 cube. When you will solve this value, you will get the answer is 30301, and on solving this you will get the final answer is 63487.81 centimeter cube, and this is the volume of the iron used in the tank is 63487.81 centimeter cube. This is the volume of the iron used in the